So hey everyone, and in this video we are going to learn about type annotations in TypeScript. So what are basically type annotations? So in the last video we have actually covered basics of TypeScript, how we can actually write TypeScript code and how it's different from JavaScript. So the main purpose of TypeScript is actually it gives you types, right? So that's what we actually call type annotations. So type annotation in TypeScript allow developers to explicitly define the types of variables. Yes, that's right. You define the variables type. For example, you can define it as a string, number, or you can define it as a void type, null type. You can define it as an array of numbers, array of strings, and so on. So we'll see all of them. So type annotation is simply defining the TypeScript variables or functions or arrays, whatever you call it. You can give them different types, whatever you want. Okay, so we'll see all those types, how many types we have, and the main ones we'll discuss them. So TypeScript supports various types, allowing developers to specify the different data types of their variables and functions. So now guys, we'll be understanding some of the most important types in TypeScript. So let's begin. Before that, I wanted to tell you one important thing, that is you can actually see this is the source code. So I'll upload today also the complete source code for today and so on. Okay, so yeah, this is the directory which we are working on. I'll just simply right click and open this, and I'll just name it as qt2. Okay, and here guys, I would just open it in VS Code. So guys, here first of all, let's create a file named as index.ts. So this is a TypeScript file, and here guys, what I'll do is I'll first of all write basic types which we have in TypeScript. So first important type is actually the number. Number can actually store integer value or decimal value or a result of square root, like that. Okay, so I'll just say, suppose we have a variable, I'll just say count. Okay, so count equals 10. Okay, and I just want it to be always a number. So later on, suppose if I say count equals suppose a, so you can actually see it giving me an error. Why? Because in TypeScript we have type inference. You can see here we didn't define any type, so by default count is taking the type of this integer. What's the type of is this integer? It's actually number. So now count is actually by default taking the type as number, and here you can see what I tried is changing the type to a. That means I am actually changing the type, right? I'm actually changing the type, so it's actually not allowed. Although we can typecast later on, but right now it's not allowed. Okay, because we were expecting a number, but you are sending a string, or you are sending some boolean value. For example, you are sending false. Okay, so whatever it is, it's expecting a number. Okay, so what you can actually do is you would always say that I am sending a number. I will always request for a number, and that's always better. So this is actually a number type. Okay, this is actually a number type. That means by default also it would become a number. If I just talk about this, it would by default become a number. Why? Because at the end it's a number. That means by default it's written like this. By default it's written like this. So someone tries to give some other value to the number type, obviously you would get an error. Suppose what if here was a string, here we gave it a string, and here we also define it as a string. So what would happen? You were expecting some string value. Suppose you were expecting some string value and you define it as a string. That means everything is fine here. But in the next step, you actually gave a boolean value. So obviously it would be a problem, right? So that's how actually the number type would work here. You would just define it as a number, and in future when you want to change the value, you would always give this a number only, else it won't work properly. Okay, so you can see, yeah, now it's working fine. Okay, so this is the number type. Now guys, after this we have one more type, that is string type. That is the string type. So what I'll do is I'll simply write it here. So I'll just write let message, and suppose here if I type if I want to provide a string, so I would always say I would have a string type of this variable, and then here I can just provide my strings. That's how you can define the string type. String type would always store a sequence of characters, paragraphs, sentences like that. Okay, so that's known as a string. I hope everyone knows JavaScript. It's same in TypeScript, right? So that's how you can define a string. Now guys, after this we have Boolean values. Boolean values are those values that is either it can be true, something can be false. Okay, so I'll just say let is done, and I'll just say this value type is Boolean. So suppose if I've defined it as a Boolean and if I give it some string value, so you can see I'm getting an error because it's expecting a Boolean and you are giving it a string, so you can't do this. So you would always give a Boolean, like for example true or false, okay, whatever you want. So you can actually give this, okay, and later on you want to change the value, you can easily change the values also, but Boolean can be changed to Boolean, string can be changed to string, right? So now guys, this is it. Now we can also talk about some important things like arrays. So if you wanna define an array, you would always say, suppose I would just create an array of numbers, and I am expecting that my array must always be containing numbers only. That means I would always say my array must always contain numbers, but accidentally someone provided a string. Okay, someone accidentally provided a string. So in JavaScript it's normal, but in TypeScript I want all elements of this arrays to be strictly numbers. Okay, so I would just say all elements of this array would be strictly numbers. That means all elements must be strictly number, and here you can see type string is not assignable to number. That means now you are getting an error because you have added one limitation here. That means all elements must be number, else in future if you are using this array somewhere and you have some operation which only works on numbers and here you have a string, so it might cause some issues. Okay, so that's why you have defined the type and you would get the issue here itself, so you can actually fix the issue at that specific point of time, right? So it's very easy, and you can see you have defined an array like this. Similarly, you can define an array of strings also. So you can actually say that I would, by the way, this is also another method. If you write it like this, I'm just talking an array of numbers. This is also an array of numbers. That's it. Okay, that's it. Both of them are actually same, right? Now I would also define it as a string also. So for example, I would just say fruits, and you can say that your string of array of strings, actually array of strings, and you can contain different kind of strings, right? And now one more thing is I'll just say let person, and I'm just saying my array would be containing only two elements. First one would be string, second would be number, right? And suppose third one would be Boolean. Okay, so I'm just defining type like this, and once you write this, it's expecting three values. Okay, so you have to give three values now. So you can see it's not assignable to type because you have to give three values also. Okay, so I'll just say false. Okay, so now you can see everything is fine. So this is also another method, but this won't contain more than three values, so you can maximum give three values of whatever values you have defined here. Okay, but this can contain any number of values, right? So that's the difference. Now what else you want is you want to say that we have other types also. For example, we have enum type. Okay, we have enum type, so I'll just say enum, and I would just say color. Okay, we have a color. Okay, we have color, some colors. Okay, so we'll just say we have red, green and blue. I'm just giving them some values also. Okay, so now guys, if I just say that my value C would be actually taken from this as an object. Okay, so I'm just saying the value of C now would be actually what, 2. Okay, so now if I just try to print this, I would get anything. Okay, I would just get I would just get 2, right? I would just easily get 2. That's how it actually works. That's how enum works. So you can actually define a set of variables like this and define it inside a type, and now you have simply given that value. Okay, so I'm just saying C would always take a value from my color. Okay, it can be any value, but C would always take a value from my color. Okay, suppose here I would just say something else. For example, if I just say 6, so you can see I'm getting an issue because 6 is not assignable to type color, right? But if I just say 1, you can see it's fine because 1 is available here, 1 is available here, right? That's the difference. Okay, so guys, I hope you understood this, and now after this we are going to continue with our next type, that is the any type. Okay, so any type is very easy. For example, I'm just going to say that let a equals 10. Okay, and I'm just saying that a would always be a number. If I have suppose said it like this, a would always be a number, but later on I want a to be some string. So it's actually not possible, right? It's actually not possible. But if I just say it's type any, so it's possible. Okay, so type any simply says it can be of any type in future. Okay, later on if you want to convert it into boolean, string, number, whatever you want, you can easily convert that, right? So any type is very helpful. Later on you can easily change the types using the any type, and if you don't know what's the exact type you want to assign, you can assign it as an any type, right? So they are very useful, and it allows reassigning any variable value to the variable and disables the type checking, right? So now guys, we have learned pretty much, and now after this we are going to learn about the void type. Okay,